Hello everyone, welcome to the course on data structures and algorithms. In this video we are going to see the different types of data structure. So basically there are three different categories. The very first category is a primitive versus non-primitive data structure. This is my first category. Second category is linear versus non-linear data structure, and third category is static versus dynamic data structure. So let us see them one by one: primitive versus non-primitive, linear versus non-linear, and static versus dynamic. So let us start with the very first one, primitive versus non-primitive data structure. So primitive is something which is fundamentally available in the programming itself, whereas non-primitive is something which is not available but user will be creating on its own. So what are those examples? Example is like if you see integer, float, character or pointer. So these are all primitive data structure because you can write something like integer x in your program, or you can write something like integer star p. So this is something which is already available. So that's why they call it primitive. But in case of non-primitive, basically it is not available in any programming language. We need to create it. But there are two different types, linear versus non-linear. And in case of linear, we can have array, we can have stack, we can have queue, we can have linked list. And in case of non-linear, we'll be having tree and graph. We'll see them one by one in our next slide in detail. And so in case of primitive data structure, you can only store one value at a time. Means you can have integer x equal to 5. You cannot have something like integer x equal to 5 as well as 10. You cannot have multiple, you cannot store multiple data values. But in case of non-primitive data structure, we will be storing multiple data values. We'll be having a stack of values. We'll be having values put in queue and linked list. So we can store multiple data values in case of non-primitive. So this is the first category. So this is another way of representing the same information, primitive versus non-primitive. In primitive you can have integer, float, character, double and all those data types along with pointer. Whereas in case of non-primitive you can have linear versus non-linear. In linear we can have array, stack, queue, linked list, and in case of non-linear we'll be having tree and graph. So we'll see this category in a little while. So second is, now let us see linear data structure. So linear, by the name itself, it should go in a line. It should go in a line. So this is a linear data structure. So what are those different types? The first is array. So we have seen in our C programming, it goes something like this. You can have an array with this many information, 58, then this 74, then 42, then 11, then 65, then 23. So this is linear. Linear means it goes in a line. It goes in a line. Then second category is queue. So queue is again a linear, but there is a difference between these two. In queue, normally the insertion is done. The addition of any item is done from one end, and deletion or removal is done from other end. So one end is for inserting and other end is for deleting. This is the property of queue. There are two different ends. The data items are inserted from one side and the data items are removed from other side. Now second is stack. So stack is nothing but a bunch of items, again in linear fashion only. But over here there is only one end. Like over here we had two ends over here. So from one end we will be inserting, and from other end we will be removing. So there are two ends, but in this case there is only one end. So insertion and deletion is done from one end only. Insertion is called pushing. So pushing is nothing but insert or adding item, and popping, or it is also called a removal of item or deletion of item. So that is done from the top of the stack. So this is nothing but top of the stack. So this is the second category. We'll see them in detail. So array, queue and stack. Now one more category is linked list, wherein the data items are linked we'll see the concept in detail, how they are linked through addressing mechanism. So different data items are linked together. So again, this goes in a linear way. So all these examples are linear. Linear means they go in a linear way. There is nothing like from one, then there are two items, and then again here you can have two more items, from again you can have three items. No, this is a non-linear structure. And in this example, in our example, whether it is array, whether it is queue, whether it is stack, or whether it is linked list, it is these all are example of linear data structure. Now let us move forward. Let us take non-linear data structure. So there are two basic examples over here. First one is tree. In tree, it is like, you know, you are having a node on the top. Sometimes they call it a root node, and from that root, you know, there are multiple nodes coming out. So there is a link between 5 and 2. There is another link between 5 and 8. Then from 2 we have two link from to 7 and 1. From 1 again there is two link from 3 to 6. So this is a tree. So this node from where it starts is nothing but root, and these nodes are called leaf node. The last node, this is the last level. This is level 0, level 1, level 2, level 3. So the last level they call it leaf node. All right. So we have you know, terminology like root node over here and leaf node over here. We have another terminology. For example, for this, if you consider just this subtree, then this is, you call it parent node. This 2 is a parent node, where 7 and 1, these two are child node. So 7 is a child of 2, 1 is a child of 2. So same way, this 5 is parent node, and 2 and 8 are children. So this is child 1 and this is child 2. Same way for other, like if you take another example like this 4. So 4 is a parent for this 9. Alright, so you need to remember few terminology like root. So root is the very first node of the tree. It's an entry point. It's an entry point. And then leaf. Leaf are the nodes on the last level, and the parent and child. So these are few words that you need to remember. Then second example of linear is a graph. So graph also, there are some you know, nodes, but we will call them over here. There is a terminology like vertex, and between two vertices there is a link, what we'll be calling edges, edge. So graph is, for example, between 9 and 7 there is a direct connection, and but between 7 and 8 there is no direct connection. If you want to go from 7 to 8, you can go like this or you can go like this. So this is how you can traverse. So over here there is a concept of vertex and edge in case of graph. So this is about non-linear data structure. Now let us try to compare them one by one. In case of linear data structure, that data items are you know, arranged in orderly manner, and they are attached adjacently. Adjacently means with every, for example, if this is a linear data structure, so if this is 45, it has two neighbors, 39 and let's say 12, something like this. The last item, for example, let's say 19, it has got only one neighbor because it's the last one, and the very first one, it has got 9, for example, 9. That means it has only one neighbor, this one only. Okay. So in case of non-linear, they have of course the relationship, as we have seen. From here we have two different, this is root and this is child 1 and this is child 2, something like this. Alright, now second is it is in single level. Single level means whether it is a stack, so it goes in single line. Whether it is sorry, this one is list, this one is stack, so it goes in a single line. So level is single, but whereas in case of non-linear, it is multiple. Multiple means from here you can have multiple. In case of graph, you can have, you know, like 2 or 3 different levels. So from here you can go like this, from here you can go like this. So in case of non-linear data structure, you have multiple level. Linear data structures are very easy to implement using array or pointers. You can implement, and these are very easy to understand also, whereas non-linear data structure, it would be little comparative to linear, it would be little difficult to implement. Examples of, as we have seen, array, stack, linked list, queue, these are the examples of linear data structure, and tree and graph are the examples of non-linear data structure. So let us take the third category, static versus dynamic data structure. So static is like, if you write in your C programming, if I write like integer x10, so this is what they call static memory allocation. Means in memory 10 elements are reserved to you. In memory 10 elements are reserved to you, x0 to x9, because we know array starts from 0. And if I take an integer as 2 bytes, so total 2 into 10, 20 bytes will be reserved. 20 bytes are given to x. Now whether we use this 20 bytes or not, these are given to you. So if you use them all, that's great, effectively utilization. But if you use only 2 elements, the other elements will be wasted. It will not be given to any other program. So this is static data memory. So memory is allocated at compile time. Compile time means before running these 20 bytes are given to you. So it is only you who can use this 20 bytes. No one else can use it. Right? But in case of dynamic memory, dynamic data structure, the memory is allocated at runtime. Means as and when required. As and when required. So it is not given in advance. Right, so this is a better way. Dynamic memory allocation is a good way to allocate memory. Now in case of static memory allocation, the maximum size is fixed. For example, integer x10, that means you can have 10 elements. That is, this is maximum, means you cannot have 11 elements. You can have anything less than 10. Means, for example, if you want 5 elements, then this is good, no problem. So 5 elements will be utilized and 5 elements will be wasted. But you cannot have 11 elements because maximum size is fixed. But in case of dynamic memory allocation, it is flexible. You can increase as well as decrease. You can increase as well as reduce the memory. If you do not need memory, you can reduce. You can free them. If you want more memory, you can always increase. Third one is example of static is array, like this, and example of dynamic is linked list. We'll see in the chapter of linked list how do we implement dynamic memory allocation using linked list. Right, and there are some advantages and disadvantages of both of them. In case of static memory allocation, it is very fast. We know that accessing array element is very fast, but at the same time, insertion. For example, we have an array like this. It is a sorted array. For example, -6, 3, then 11, 39, 45 and 89. For example, this is a sorted array. Now I wish to insert something into here. For example, between 3 and 11 I wish to insert 8. Then in that case, what you'll have to do, you'll have to shift all elements. You'll have to shift all elements by one position. That means this -6 and 3 will remain at their position only, but this 11 is to be shifted to this position, this is to be shifted to this position, this is to be shifted to this position, and this is to be shifted. So let us start from 89. 89 is shifted here, next position, then 45 is shifted here, then 39 is shifted here, and this 11 is shifted here. So now you can say there is a hole created, there is a space created for this, and then you can push this 8. So in case of insertion, so many shifting is required. And same for deletion. Supposing you wish to delete this number 3, you cannot simply delete. You need to override this 3 by 8, then overwrite 11 by 8, 8 by 11, then overwrite 11 by 39, overwrite 39 by 45 and overwrite 89 by 45. So insertion and deletion is very slow. For inserting one element, for deleting one element, you need to disturb all other elements. And of course the memory wastage, because if you write something like this, if integer x equal to 100, that means 100 elements are reserved for you. Now whether you use it or not, if you just use 2 elements, then 98 elements will be wasted. This is the case with this static data allocation, whereas in case of dynamic data allocation, insertion and deletion is faster. We'll see, we have in case of linked list something like this. We'll be having a list wherein multiple nodes are added to each other, and supposing I wish to add something over here between these and these, all I need to do is, instead of this arrow, instead of this pointing to this, I need to push it over here, and I need to push it over, push it over here. So this will be inserted over here. So this is how you can do insertion. Same way for deletion also. Supposing you have a list like this, wherein the first element is pointing to second, second is pointing to third, third is pointing to fourth. Now if you wish to delete this one, all you need to do is just change this arrow from here to here, and now this is removed. So this, in this one dynamic data structure, insertion and deletion is fast, and memory is also saved, because as you need memory, you will be allocating memory. When you do not need, you will be removing. And the disadvantage is access is slower. Alright, and because of these pointers, extra memory, there will be some computational overhead too in case of dynamic memory allocation. Now what are those different operations that we perform on data structure? So first is search, or sometimes they call it traversal. So first is searching a specific element or traversing through the list for a specific element. So for example, I want to search 11. So check, this is 11, no, this is 11, no, this is 11, no, this is 11, yes. So what will happen? You will find 11 and position, let's say this is 0th position, first position, second position. So you will find 11 on position number 3. The second operation that we perform on data structure is sorting. For example, this element, so I'll be sorting, like this is ascending order. Alright, so 11 is the smallest one, 74 is in. So second operation that you do on any data structure is sorting. Third operation is about inserting any element. For example, on sorted data I wish to insert 49. So you can see 49 would go somewhere over here between 42 and 58. So what we'll be doing, that as we have discussed, 74 will be shifted, then 64 will be shifted, then 48 will be shifted. So 74, 65 and 58, and the whole is created wherein we'll be pushing the new element that we wish to insert. So next particular operation is insert. Then same way you can do delete also. For example, I want to delete 23. So let us see, 23 is there, yes. So what we'll be doing, we'll be moving this 42 over here, we'll be moving 58 to 42 place, we'll be moving 65 into 58 place, and we'll be moving 74 into 65 place. So you can see that one now space is removed. This is how you delete a specific element from a data structure. Now update means changing a specific number. For example, a specific number like 58, you wish to change it to 59. So everything will be there, will be just changing 58 to 59. So these are all the operations that we are going to perform on a particular data structure. So I thank you everyone for watching this video. Now in our next presentation, next video, we'll be talking a specific example, that is sparse matrix in case of linear data structure.